Hello students, I am Professor S.D. Sheikh. Welcome you all in this new video. In this video we are going to learn how to draw working drawing of plinth beam. All of you know there are two types of drawings, submission drawing and working drawing. Generally submission drawings are prepared for submission purpose, that is plan, section, elevation, includes all the details of structure etc. called as submission plan. So engineer have to prepare submission plan according to the scale and according to the FSI, that is floor space index of concerned region. And another drawing is working drawing. So working drawing is generally preferred or prepared for the purpose of actual working on site. These plans are handed over to the concerned contractor, maybe RCC contractor, maybe brickwork contractor etc. for the actual work. So labor will understand the language of working drawing. So it is necessary for all to know how to draw working drawing of different structural elements. Now in this video we are going to learn how to start or how to prepare working drawing of plinth beam. Okay, so in previous video we have seen how to draw foundation plan, then centerline plan. Okay, first of all we will discuss about centerline plan, what we have discussed. In centerline plan, this is a centerline plan that we have prepared in previous video. In this plan we have prepared center to center distance between columns by referring one starting point called as space. All the dimensions of columns are given, their orientations are given. On the basis of that, centerline plan is prepared. So after centerline plan, it is necessary to know what are the different reinforcement details of column. Sizes are known, but reinforcement details are unknown. Excavation of footing is also unknown. So before that, before going for plinth beam, it is necessary for all to know about the details of footing, that is footing size, footing depth, excavation depth, size of footing, depth of footing, size of column, and reinforcement details of footing and column. So all these important elements to know. Okay, so we will see one by one. Okay, if you see load on column, okay, first of all column number 1, 2, 3, all the three columns are external columns or having a load of one beam, two beam. Okay, one beam, second beam, first beam, second beam, first beam, second beam, means column number 1, 2, 3 is having load of two beam and wall constructed over it, also a load of slab. Column number 4, column number 5, column number 6. In these, column number 4 is having load of two beams, first beam, second beam. But column number 5 having load of four beam, first beam, second beam, third beam, fourth beam. Consecutively, the column number 5 having more load as compared to 1, 2, 3, 4. Okay, now let us talk about column number 6. Column number 6 is having load of 3 beam, beam number 1, beam number 2 and beam number 3. Okay, so these column having self weight of beam, wall constructed over the beam, load of slab and other live load etc. So column number 5 and 6 having more load. Column number 7 is having regular load, or we can say it is also having the load of three beams, beam number 1, beam number 2, beam number 3. It is also one of the big column we can say, or having more load. Column number 8 is having a load of two beam, 1, 2. Column number 9 is having load of 1, 2 and 3 beam. Okay, column number 10 is also having load of column number beam number 1, beam number 2 etc. So we will split columns into two parts. Column is having less load, column is having more load. So according to the loading criteria, after applying all the design criteria that we will you will study in B, design of beams, RCC design. So but in second year level you should know the different reinforcement details only. How to design it, it is another part. Okay, but in this video I will tell you how to give dimensions, how to give reinforcement details, and how to fix the number of bars. Okay, so in this we will split 10 columns into two parts: column number 1, column number 2, column number 3, 4, column number 8. Okay, so all these are in one group: column number 5, 6, column number 7, column number 9 and 10. So these are in second group because these are having more load as compared to others. Okay, so let us see the schedule. This type of schedule you have to prepare. You can say reinforcement schedule. Reinforcement schedule. Okay. So serial number 1. Okay, in this column number 1, column number 2, column number 3, also column number 4, then 8, column number 8 are in one group. Second serial number, column number 5, column number 6, also column number 7, 9 and 10. Column number 7, column number 9 and column number 10 are in second group. So in this way the columns are split into two groups. So first of all, excavation size. Excavation size should be like this: 1.7 meter along its length and 1.5 meter along its width. If size of column is like this, 0.23, 0.45, then excavation detail should be like this: along the length excavation, along the width excavation. So along the length 1.7 meter, and along the width 1.5 meter. Likewise you have to prepare the excavation size of footing or excavation trench, we can say, in which footing will be casted. Okay, now footing size, it should be less than excavation size, 1.5 meter by 1.3 meter. Okay, reinforcement of footing. Okay, if you see reinforcement detail. Okay, so with the help of this diagram you will understand how to draw excavation details and footing size. So this red marked area is excavation size of footing. Okay, for column number 1, 2, 3, 4 and 8, 1.7 meter along the length, 1.5 meter along the width. Okay, then footing size, you can see the footing size internal block having 1.5 meter along the length footing and 1.3 meter along the width, and the 0.1 meter, that is 100 mm and 100 mm are the what we can say the distances, marginal distances, which are necessary to put up the reinforcement, put up the formwork. Okay, then footing size is also over 1.5 meter by 1.3. Okay, for the second group, column number 5, 6, 7, 9 and 10. Okay, for this give excavation size 2 meter by 1.8 meter. Okay, in this along the length footing size is changed, that is 2 meter, along the width 1.8 meter, because this group having a column more loaded, therefore more area of footing should be provided. Okay. So along footing size should be changed along the length and along the width. It should be 1.8 and 1.6 along the length and along the width meter. Okay, so in this way this is 1.8 by 1.6. so in this way excavation size and footing size for the two groups of column are given. Now reinforcement details of footing. How the reinforcement details are given, let us see. Okay, with the help of figure number 2 you will understand reinforcement details of footing and column. Okay, so in figure number 2 reinforcement details of footing is mentioned. We can see the bars in red color and bars in black color. Bars in red colors are main bars along the width. Main bars are provided along the width, short side, and for long side distribution bars are there. Okay, so main bar and distribution bar. There are spacing which are also mentioned. There are spacing in between main bar. So 0.1 meter center to center distance between, or we can say the distance between two bars are 0.1 meter. That is 100 mm distance between two main bars and 150 mm distance between two distribution bar. So understood this concept, main bars are provided along the width, that is shorter span, and the bars which are provided along the length for the longer span are called as distribution bars. So the spacing between two distribution bar are 150 mm, that is 0.15 meter, and the distance between two main bars is 0.1 meter, that is 100 mm. Okay, so in this way the reinforcement of footing is mentioned. So reinforcement of footing you can write down here. 10 and mainly the 10 mm diameter bar are used for both the sides, for distribution bar and for main bar also. Okay, so reinforcement of footing, 10 mm distribution bar and main bar are provided along the 100 mm center to center main bar. Okay, you can understood with the help of this reinforcement of footing. So main bar is provided along the shorter span of 10 mm diameter at 100 mm center to center, that is distance between two main bars is 100 mm, and distribution steel, that is shown in black color, 10 mm 5, that is 10 mm diameter bar are provided at the center of 150 mm center to center, that is distance between two distribution bar is 150 mm, and same details are given to second group also. Now the reinforcement of column, all of you knows size of all columns are same, that is 0.45 by 0.23 meter. Okay, but there are two types of column. One is lightly loaded and second is heavily loaded. For lightly loaded column, reinforcement details are different, that is 12 mm bars are used. Okay, so 6 numbers of 10 mm bar or 10 mm diameter bar are provided. Okay, and for heavily loaded column, 8 numbers of 10 mm 5 bars are provided. Okay, and for all the two groups, 6 mm diameter stirrups is used. All of you know stirrup is generally used to bind the bars of all column. It should be in rectangular shape if column is rectangular, like this. This is stirrup, 6 mm diameter, and for 6 is also 6 mm diameter provided at 150 mm center to center. So distance between two stirrups are 150 mm, that is 0.15 meter center to center. Okay, that means, for example, this is columns, this is bar provided, and these are the stirrups are provided. If you see the elevation of column, and then the distance between two stirrups are 150 mm, like this. Okay, so in this way reinforcement details of footing and columns are over. Okay, now secondly we will see how to draw plinth beam drawing. Okay, so first of all take a review. In previously we have calculated all the details of center to center distance between columns, orientations of columns are given, their sizes are fixed, and accordingly we have prepared this reinforcement schedule. Columns, all 10 columns are split into two groups, heavily loaded column and lightly loaded column. Serial number 1 lightly loaded column and serial number 2 heavily loaded column. Excavation size, their excavation size, footing size are mentioned in figure number 1, and reinforcement details of footing and column along with stirrups are mentioned in footing number or figure number 2. Okay, and I hope you understood all these details. So this is all about the today's video. In next video I will tell you how to draw details of plinth beam. So here I have prepared plinth beam drawing. So how to draw these plinth beam details, this reinforcement details, we will see in our next video. Thank you for watching this video.